Okay, now that we've talked about the test-retest reliability results, let's take a look and see what was determined by criterion validity. Criterion validity was determined by assessing relationship between the three self-reporting outcome measures which were completed concurrently. There was a high correlation between the ULFI and DASH with a Pearson's coefficient of 0.87, while the UEFS, the correlation was 0.78 and 0.77 respectively. So they looked at the relationship between the three to determine if there was criterion validity, and they determined that using the Pearson's correlation for the ULFI and the DASH was 0.87, while with the UEFS the correlation was 0.78 and 0.77. Now let's take a look again really quickly at what correlation is. Just as a reminder, correlation is looking at relationship between variables. So is there a relationship between those variables? Is it positive or is it negative? And in this case, all of them ranged, let's just go back, 0.87, 0.78, and 0.77. These are still considered pretty high, but let's take a look at the chart. Table 5, let's go down to Table 5 on page 338 at the very top. It shows you the same thing in a graph or table version of what they explained. So the ULFI compared to the DASH is 0.8665. That's high. Of course, you don't compare the ULFI to the ULFI, so there's no comparison there. The UEFS compared to the DASH was 7.67, which is considered medium. Still pretty high, as it is still closer to 1 than it is to 0. Just not as high as the comparison or relationship between ULFI and the DASH. They also compared the UFS with the ULFI, which also was around 0.775 which is considered medium. Now let's go back up to the page we were reading. So that's what they determined was the relationship for criterion validity. So all three self-reporting outcome measures were looked at for criterion validity. There was high correlation, okay? That's a good thing. Now let's look at construct validity, which was investigated again in the three ways. The distribution analysis, looking for floor ceiling effects, the known group method, and then also the response. So let's read this. Construct validity was investigated in three ways. As previously mentioned, distribution analysis was demonstrated as relatively normal with limited or no ceiling or floor effects found for either the ULFI or the DASH. The UEFS did not demonstrate this normal Gaussian distribution capacity. So they talked about that a little bit earlier. The UEFS had some skewedness versus the ULFI and the DASH. Further analysis of distribution in the area of proximal versus distal, general, and then central components of the limb indicates a normalized distribution tendency for the ULFI and the DASH, but again, not for the UEFS. And we'll take a look at those figures. However, both the ULFI and the UFS had a higher distal mean while the DASH did not, The known group method compared baseline and follow-up scores where a simple difference t-test exceeded the 0.95 level, supporting the construct validity of the ULFI and DASH. So, as we know, using the t-test, construct validity was determined for the ULFI and the DASH. The response severity order has a reference marker at each of the 5 separate 20 increments. Now, I'm actually going to stop here for this section because in this portion, of the results talking about construct validity, they're actually focusing on Table 6, which actually is not in this article anywhere. So we're not focusing that much on the response severity order to begin with, so don't get so caught up in these numbers. The ULFI, and I'll still read them, but the chart is not available for you. So we're going to focus on the two types that were discussed, which is the distribution analysis and then the known group method, which would use the t-test. And the point is to show here that construct validity was proven for the ULFI. And construct validity was seen for the ULFI and the DASH, but it's not mentioned for the UEFS. So I'll still read this section, but note that this chart, Table 6, is actually not available in this article. The response severity order, Table 6, has a reference marker at each of the five separate 20% increments. The ULFI has items in each category with a range of 77.7% from 15.5 to 92.5, and the DASH registers in the final four categories only with a range of 53.7% from 26.9% to 80.6%, and the UFS registers in the final three categories only with a range of 28.8% from 55.5 to 84.3. All of those stats in those sections is focusing on the response severity order, which is a little newer. However, a chart is not available for you to see that in a graph or a table version. They're just providing you with the results in their written version. But the point to take from this is that construct validity was determined. Now, they also, again, still looked at missing responses within the article, and they did an analysis to indicate that the ULFI indicated only one questionnaire affected in all subjects, as there was no provision on a confirmatory negative response. However, 48% of the respondents used a negative indicator such as an X as opposed to a check mark within the box. The DASH had 34% missed responses from the 19 different item questions in question 21 pertaining to disability with sexual activity, accounting for 27.5% of all missing responses, while question 18, recreational activities with some force, accounted for 8.5%. So essentially they're telling you what were the percentages of the missing responses and where were they most likely to be found in all of the patients or the subjects that utilized the questionnaires during this study, or multiple studies from the pilot study moving forward. Again, knowing how many responses were missed and understanding why is important as well. So, Figure 3, again, we talked a little bit about, but this is the response categories. They had 8 groups with whole numbers looking at the ceiling and floor effects for all 3 studies. Table 3, we talked about a little bit already. This focuses on the the test-retest reliability and the interclass correlation, the inferential statistic that was used to determine reliability. And again, those numbers are high. They're closer to 1. So that's high correlation. That's a good thing. Now I'm going to go back up a little bit and talk about the responsiveness to change, because responsiveness is also something that we focus on when we look at outcome measures. The study did focus on responsiveness to change, so let's see what they talked about. In the results, this is still the results, responsiveness to change using longitudinal measures of disease impact for SRM and ES effect size are shown in Table 4. We will go down to Table 4. These values were determined only for the DASH and the ULFI from the subgroup N equals 24, which is essentially the subgroup that had 24 patients or 24 subjects. And they based it on a cutoff criteria of 10.7% of a change or 12.8 actual DASH points. So the minimal detectable change was based on 10.7 percentage change or 12.8 point change. And that's DASH points, of course, because it's using the DASH. Let's go down and take a look at Table 4. And let's see what they're talking about. Now, table 4, here we are. So the same thing that's written in Word form on page 336 is in a table form on page 337. So this is what we're looking at. Table 4, methodological characteristics for the DASH, the ULF-5, and the UEFS. Let's take a look and see what we have here. Take a minute to just look at this chart. I actually want to start with the effect size because this is often the thing that is confusing individuals the most within this. So again, let's just talk about what effect size is one more time, okay? What is effect size? And why is it important? Effect size is, again, a simple way of quantifying the size of the difference between two groups. Generally we'll look at statistical significance, which is there a change? Or is this therapy better than the other therapy? Or is this intervention better than the other intervention? But sometimes just knowing if a therapy or an intervention is better than the other is not enough. We also need to know how much better is a therapy or how much better is a intervention. So the effect size provides us with that information. Effect size can be interpreted in many ways, and it is exactly equivalent to a z-score. So our whole background information about the z-distribution, the z-table, the effect size is is equivalent to the z-score of standard normal distribution. So the higher the number, generally the better the effect size is. Okay, so anything that's 0.8 or better is generally high. Anything between 0.45 to 0.6 is considered medium, and anything below that is considered a low effect size. For an effect size to be considered as quote unquote good in a sense, you generally want a high effect size. And there are multiple ways to calculate that effect size, but just kind of focus on that general rule. In this case, they looked at the effect size for the DASH, the ULF-5 only. They were not able to come up with the effect size for the UEFS. And they did determine that the effect size for both were pretty high. It's a 1.40 for the DASH, and the effect size for responsiveness is 1.28 for the ULF-5. Both of these are good effect sizes. Let's take a look at what else you see. You also see, again, the interclass correlation. They're just putting that information back in there. Again, those numbers are high. They're closer to 1. That's good. They just looked at standard deviation. SEM. If you remember, we talked about this being the standard error of measurement. We have to know how much error is allowed for that true value to fit in and to know that that true value can be true, because we'll never truly know what the actual true number is. So we have to determine how much error is due to chance and not because the actual outcome measure is invalid. So they also measured for the standard, or they use the standard error measurement. They have 2.8 for 4%, 4.5%, 5.51. Now you may be asking what is considered a good standard error of measurement. There's no real right or wrong answer to what's considered a good standard error of measurement. The higher the standard error of measurement goes, though, the less reliable the tool is, because that's more range for error. The smaller the standard error of mean is, the smaller the standard error of measurement is, that means that there's more reliability. So that's one way to look at that. Again, you are given the minimal detectable change at 90% confidence interval and a 95% confidence interval. And those numbers were also described previously. And you're also giving the C alpha, which we talked about before. This is also based on correlation, so those numbers are going to be higher. The closer they are to 1, the higher the relationship or the higher the correlation. The lower they are, or the closer they are to 0, the less relationship there is. So that's just a basic breakdown of Table 4. Table 5 we've already discussed. And that's pretty much the basis of what you need to understand for the article. I'm not going to discuss the discussion.